Okay, now we're going to talk about inverses of functions. This is something we actually learned really quickly right before the exam, and there's only 2 steps. The first step is to switch x and y, and then the second step is take that after you switched it and just solve for y. Solve for y. Once you have that, we no longer call it y, we'll call it f inverse. That's the this is like the symbol that we use for inverses. And then the next couple of slides will show a couple of examples, but then also what that means graphically to a function. Okay, so for the first one, f, this is in your workbook, by the way, on page 148. F is the function and g is the inverse. And so what we're going to do is prove it. So instead of f of x, I'm going to make it y just to make it a little bit easier. And that'll be, there we go. So the first step, like I said, was to switch the x and the y. So basically you just replace them. So this will be x equals 4y plus 3. And then the second step is to solve for y. So I'm going to have to subtract 3 to the other side. So this will be x minus 3 equals 4y. Then I'm going to divide by 4. And so if you'll see now, this function, which is the inverse function, is the one that they said is the inverse. Okay, so let's see what that looks like in B. Again, we'll call this y equals x cubed plus 1. First step is to switch the x and the y, so that would be x equals y cubed plus 1. And then second step is to solve for y, which means I need to get the 1 to the other side. And then we already know how to solve for y cubed would be to cube root. And cube root the whole thing. So our answer, which is actually now, let me take that out, will actually be the inverse, is the cube root of x minus 1. We're going to use Desmos to show kind of graphically what the original function and its inverse have to do with each other. So I'm going to go ahead and type in the first example we just did. I'm just going to use y equals because it's easier on Desmos. It would be y equals 4x plus 3 was the original function. And so it's plotted there in green. And then the second function, again, we're going to use y equals, but just know it's supposed to be the inverse, will be x minus 3 and then over 4. So we already found that those two things are inverses of each other. So what happens with an inverse is that they are flipped over a line. So you know in class we've done like a function that's flipped over the x-axis and flipped over the y-axis. Well, what happens is in an inverse is the original graph and the inverse are flipped over what's called the y equals x graph. And it makes sense. If we switch the x and the y from the beginning, then that should kind of correlate that they would be flipped over the x-axis a little bit. Let's see if I can change, see if I can change this graph's looks. I don't know if I can or not. Okay, so apparently not. But the purple line that's in the middle is the reflected line. Okay, so that's what happens in the first one. Now the next one might be easier to see. I'm going to leave the y equals x there, but I'm going to change this this graph to be the second example we had, which was which was x cubed. And so x cubed plus 1. So that's the green graph, and we said that its inverse was the cube root. See if I can figure that out on here. Okay, I don't have a cube root, I don't think. So what I'm going to have to do is make it x minus 1 and then raised to the 1/3 power. And you guys should know what that means now. So that's using everything that we've learned. Oops, I don't know what all that is. Okay. There we go. Okay, so x minus 1 to the 1/3 power is the same as the cube root of 1. So look at the green graph and the orange graph. they are also reflected over what's called the y equals x graph. Okay, so that is essentially what an inverse is. Okay, let's do a couple more really quick. This will be a pause and play, which means I want you to try it by yourself and then hit play to see how you did. All right, so again, the original, oh, I'm sorry, that's not step one, this is the original. Now step one will be to switch x and y. And then step two is to solve for y. So in this case, I'm going to square both sides. X squared is y minus 3. And then I'll add 3 to both sides. So I have y equals x squared plus 3. Now again, we don't want to use y, we want to use some other symbol. They use g of x because in the instructions they said that g of x was the inverse. Again, the universal symbol for an inverse looks like this. And also I want to highlight why they have this x greater than or equal to 0. They have that because x can't be a negative to give us this answer here if we were to work backwards. Okay, so that's the only reason why that's there. As long as you give me the inverse correctly, that's all I really care about. All right, now the next one's a tad bit tricky, but follow along with me. I'm sure you can figure it out. All right, so first step again is to switch the x and the y's over y plus 5. Okay, so now what we want to do is I'm going to multiply both sides by y plus 5, mainly because I don't like denominators. So I'm going to multiply this side also by y plus 5. Then it's just going to be a little bit of algebra sense. All right, so here I'm going to distribute. I'll have xy plus 5x equals 4y plus 4. I want to get my x's and y's together, so actually I want to move this x over there with the 4. I'm going to move this y. Let me show you one step at a time. That's 5x. So the xy equals 4y plus 4 minus 5x. Then I'm going to move this 4y over here. You'll see why in just a second. But so far I have, let's see if you can follow me over here, xy minus 4y equals 4 minus 5x. Now I can cancel out, factor out a y. I'm left with x minus 4. Oops, equals this. And then when I divide by x minus 4, sorry, you can't really see that, it will look like my answer up here at the top. Okay, so bring questions for that tomorrow if you need to. We can go back over it.